Hey guys, what's up? Have you ever heard about container? And when you hear the words container, what comes to your mind? Do you have any idea about how it works? Well, that's exactly what we're going to talk about. In this video, I will show you and I'll explain to you what is container, the basic concept, and how it works, using one example of the container that really highly recommended to try. So yeah, let's get started. I'm currently taking a course from Red Hat about Podman, and now I'm already on the course page. It looks something like this, but before I continue, I want to explain first what exactly is Red Hat. So, Red Hat is a pretty big and well known tech company in the IT world, especially in the open source space. They're known for developing a Linux based operating system called Red Hat Enterprise Linux, if I'm not mistaken, which is widely used by big companies, especially for server and enterprise needed. On top of that, Red Hat also provide a various tool and IT solution like cloud computing, automation, and containerization. So a lot of technology used in the professional worlds are actually connected to Red Hat products or ecosystem. And not just that, Red Hat also has official learning platform and training programs that we can join to learn this technology. And one of them is a Podman course that I'm currently taking. So you could say Red Hat isn't just a company that builds software, but also a pretty trusted place to learn IT. So in this course, there are 9 sections over here, where each chapter consists of several sections and each one covers different material. So now let's jump into the section. We're entering the introduction part of the course. The course is called Red Hat OpenShift Development 1 Introduction to Container with Podman. From the name itself, you can already tell that this course focuses on learning container, especially using Podman and OpenShift. In this course, we'll learn how to build container, run them, and also manage them. And the interesting part is it's hands-on, so we'll be doing a lot of practice, not just a theory. This course is based on Red Hat Enterprise Linux 9, Podman version 5, and OpenShift version 4.18, so it's pretty up to date with current industry standard. And this is the information about objective, target audience, and prerequisites. Now, if you look at the objective, the main goal of this course is to help us build and manage container using Podman, and then deploy them to Kubernetes or an OpenShift cluster. It also prepares you if you want to take a Red Hat certification exam. So, who is this course for? It's mainly for developer and site reliable engineers, especially those who are new to container technology. And for the prerequisite, it's recommended if you have some basic understanding of web application, know how to use Linux, are comfortable with the terminal, and have a bit experience with shell scripting. But even if you don't expert yet, you can still follow along while learning, just like me. Alright, now we'll move on to chapter 1, Introduction to the Container. So what exactly container is? From a simple perspective, you can think of container as kind of box or environment where we can run an application. Inside this container, everything application needs is already included, like library, dependencies, and configuration. So the app can run properly without relying too much on the operating system. Now, normally if we install an application directly on OS, we might run into problems. For example, imagine you have 2 applications. App X needs Python 3.8 and Flask 1.0, while Apps Y needs Python 3.9 version and Flask 1.1. If we install everything directly on the OS, you often only have one version of Python and Flask active at the time. You can try to install multiple versions, but it can get messy. And worse, it might break the apps that originally built for a specific version. This is where containers become really useful. Containers allow us to create separate environment for each application. So the app X can run in its own container with Python 3.8 and Flask 1.0, while apps Y run in a different container with Python 3.9 and Flask 1.1. They don't interfere with each other at all. Another big advantage is portability. Once your application is packaged inside a container, you can move it to any server, as long as the server has a container engine installed. So basically, containers make application more consistent, isolated, and easier to deploy anywhere. So in this chapter, there are a few parts we'll go through, like introduction to container, introduction to Kubernetes and OpenShift, and a summary. So basically, this chapter gives us the foundation before we go deeper. The main goal here is to understand how containers help in application development. And the objective are understanding the basic of container knowing and difference between container and virtual machines and getting introduced to Kubernetes and OpenShift. But the thing that you have to know is not everything is inside the container. Some parts like operating system kernel are still shared with the host. That's why containers are lightweight and fast. This is also why container can start and stop really quickly compared to virtual machines. Now, behind the scene, container use something called image layer. These layers are read-only, and when a container runs, it adds writable layer on top. And by default, containers are ephemeral, which means when you delete them, all change are gone. Containers also rely on Linux feature, like namespace is to isolate a process, CG groups is to manage resource like CPU and memory, so even if you run container on Windows, under the hood, they still depend on a Linux feature. So even if you run container on Windows, under the hood, they still depend on Linux features. Image versus container. So what is the different thing between those two? An image is like a blueprint and a container is the running version of that image, so they're totally different things. Let's think of it. It's like a class, an object, and the programming. Isn't it? Okay, we'll talk about it later. But what if we compare container and virtual machine? Most of you gonna asking what is the different thing between container and virtual machine. Are they the same? They're not. Both are used to isolate application, but they work very different. Virtual machine is used a hypervisor, include a full OS, and way much heavier, is usually in gigabyte. And container use a container engine like a Podman. It shared the host OS kernel, and it much lighter, usually in megabyte. And it also start way faster. Virtual machine is still useful if you need a full OS or different kernel, but I'm gonna tell you containers are better for lightweight, fast, and scalable application. Now, why developer love container? Container makes development easier because you can test locally and deploy anywhere. They work great with CI or CD pipelines. They ensure consistency between environments, so what works on your laptop will also work on the server. You can also build multi-container application. For example, one container for the web app, another for the database. And they can run independently but still work together. Okay, so we're finished about the chapter 1. Now we'll move on to the chapter 2, Podman Basic. Alright, in this chapter we're going to talk about Podman Basic, how to create container, run them, connect them, and manage everything step by step. So let's jump into it. Creating container with Podman. First, what is Podman? Podman is a daemonless container engine, which means it doesn't need a background service to run. This makes it more secure compared to the other tools like Docker. Now, before running a container, we need something called an image. Think of it. It's like this. As we know, image is a blueprint and container is a running application. To download an image, we use a Podman pull, and to run it, we use a Podman run. For example, we can run a simple command inside a container, and boom, it executes inside an isolated environment. Also, there are some important options you should know. Min name, to give your container a name. And this one, min rm, to delete after it stops. Min d to run in the background. Min p to open the ports. Min e to set environment variable. Now let's talk about networking. Containers don't just magically talk to each other. We need to connect them using a Podman network. You can create a network like this. Podman network create. This is a command we use to create a network. Then attach container to it using a min name. Okay, here's the cool part. Container in the same network can communicate with DNS enable. They can use container name instead of IP address. This is super useful, especially in the real-world apps like front-end or UI, back-end or API, and database. Each can be separated but still connect securely. Okay, accessing container. Sometimes we need to go inside the running container, and Podman gives us a tools for that. Run command inside the container is a Podman exec. And for open terminal inside the container, we can use a Podman exec min-it. Now you can debug, collect logs, or explore a file. You can also copy a files with the command podman cp. Important concept here. Containers use a layer, and only the top layer is writable, which means any change are temporary and lost when the container is deleted. Managing the container lifecycle. Now let's manage a container. To see the running container, we can use a podman ps. To see all, we can use a podman ps min-a. To stop it, we can use podman stop. And to force it, we can use a podman kill. To restart it, we can use a podman restart. And to delete it, we can use a podman min-rm. And yes, stopping is not the same as the deleting. A stopped container still exists until you remove it. Alright, so in the chapter 2, we'll learn how to run, stop, restart, and delete container. Now let's level up. Because here's the truth. Container are nothing without image. Now we're entering a chapter 3, and this is where things start to feel real. So before we run in container, where did those container actually come from? The answer is container image. So a container image is basically your application, all dependencies, runtime environment, and everything packed into one. So instead of installing things manually, you can just pull and run. Another super important thing in the container world is container image and where they live. So here's the deal. Container image are stored in something called container registry. The easiest way to understand this is like GitHub. Instead of storing code, it stores container image. That's basically your central place to upload, download, and manage image. Now, there are few popular registry you'll see a lot. For example, there are Docker Hub, Red Hat Registry, and etc. These are like a big warehouse where images are kept and shared. So anytime you run a command like podman pull blah blah blah, what you are actually saying is, hey, go to that registry, find this specific image, and download it into my machine. Simple as that. Now let's time to break down what an image name actually means. Because, yeah, it can look a bit scary at first, but take this example. registry.access.redhat.com/ubi9/node.js/18 latest. Here's how to read it. The registry is where the image is stored. The namespace is like the organization or owner. The image name is the actual application and the tag in the version. And please remember this one thing. Reading image names become way easier. And please remember this one thing. Always use full image names because if you just type something like Podman pull engine X, you might accidentally pull the image from the default or unintended source. That's how mistakes happen. Now let's talk about authentication. Some registry are public, meaning you can access them without logging in. Others are private, so you need a credential. For example, this one, the login needed, registry.access.redhat.com. And for the login required is registry.redhat.io. If login is required, you just run podman login registry.redhat.io and then enter your username and password and boom, you're in. You're successfully logged in. Alright, let's break down custom container image, but in a more streamlined way so it's easier to follow. So first, we'll learn how to create custom container image using a container file. It's like a recipe that contains step-by-step instruction to build an image layer by layer. We also choose a base image. It's like a UBA from Red Hat, which becomes the foundation. Then we use instruction like from, run, copy, CMG, and entry point to define what goes inside the container and how it runs. Along the way, we also introduce to the best practice, making image smaller, cleaner, and more secure, and the concept of running container without root access. In the guided exercise, we actually build an image from container file, tag it as something like hello server bat, and run it using Podman while exposing a port. Then we test it with curl and inspect the image layer to understand how the build process works. After that, we improve the container file by making it cleaner and adding work there. Then rebuild it as hello server better. Finally, we optimize it even more using a proper runtime based image like Node.js, resulting in hello server best, which is more efficient and structured. Next, about persisting data, here is super quick explanation. So the key idea is data inside container is temporary. If the container is deleted, the data is gone. That's because container only store change during a runtime. To make data persistent, we use mount. Being mount connect folder from the host into the container, but we have to handle the permission manually. Volume are easier because Podman manage them, and the data stays safe even if the container is removed. Then we move the database. Since the database is stateful, they need persistent storage. We compare the temporary container or data loss versus the persistent ones using volume. We also set up networking and tools to manage the database. In the Vinyl Lab, in this chapter, we combine everything, which is volume, database, backend, and frontend, all connected in one network. Debugging is about how to expose a debug port and connect from the outside container. We also use a bin mount so any code change on the host are instantly reflected without rebuild the image. And then we also use a Podman Compose to run multiple containers at once, like database, backend, and frontend. It's just using one YAML file and a single command. So the takeaway is simple, like fixing error, debug efficiently, and run multi-container application like a real DevOps. Next, Kubernetes and OpenShift are used to deploy and manage containerized apps. Then, pods are created as smallest unit, either with YAML or commands. Commands like oclogin, ocget, ocreate, ocdelete, and oclogs are used to access, manage, create, delete, and check logs. After that, service connect pods so they can communicate reliably. Next, deployment manage pod automatically handles scaling, updates, and recovery. And then multiple pod apps connect different components like front-end and database using service. And finally, routes expose application so they can be accessed from outside the cluster, and lab focusing on fixing config and ensuring apps run properly. The most interesting part of this material is how containers solve real-world problems, especially dependency conflicts between applications. The idea that each app can run in its own isolated environment without interfering with others is very powerful. However, the most challenging part to understand is container orchestration, especially concepts like deployment, service, and how multiple pods communicate automatically in the Kubernetes and OpenShift. In terms of benefit, this material is very useful for future learning and career, especially in the field of cybersecurity and cloud computing. Understanding container, Podman, and orchestration tool like Kubernetes and OpenShift is essential for modern system deployment, DevOps practice, and even security analysts, since many real-world infrastructure now rely on containerized environment. In conclusion, I have learned a lot about the fundamental concept of the container from this course, how they differ from virtual machine, and how they simply application development. We also explore how to run and manage container using Podman, including networking and lifecycle management. And finally, I also learned about how Kubernetes and OpenShift help us in the scale application and making them more reliable and production ready. And last but not least, if you want to go further, try exploring advanced topics like container security, Kubernetes networking, or CI or CD integration with container. That's all for me. Thank you so much for watching. Wassalamualaikum warahmatullahi wabarakatuh.